All right. We're back. Yeah. Let's do this. Next episode of This One Time. My name is Andrew Gillies. I'm the CTO and co-founder at Urban Machine here. And as always, joined by Jory Wisniewski, who is the marketing lead at Urban Machine. And today we're going to be doing Intern Day. We have our summer interns here. Super fun to share all the cool projects that they've been working on. And just before we jump into that, real quick, just a background on This One Time. So at Urban Machine, we're building a large lumber reclaiming robot to help improve circular economy in our built environment. And we're building hardware, we're building robots, and as they say, hardware is hard. People say that a lot, but you don't usually get the context and the details of what actually makes it hard. What are all the challenges? So at this one time, we're sharing those nitty gritty details. We're kind of lifting up the rug, looking underneath, and we're sharing all that information in the hopes that maybe it'll help someone else accelerate their project a little bit. There's lots of folks working on incredible hardware. Atoms are what the world is made of, so we have to work on these projects in order to solve these gnarly problems. And yeah, hopefully this will just help people move down the field that much faster. So we're going to kind of do a little bit of a roundtable here. So I think what we'll do is we'll have you guys introduce yourselves first, and we'll start with Samuel on the far end here. Yeah, so kick us off.
Hi everyone. I'm Samuel. I was in Berkeley for the past year, and I'm doing software engineering at Urban Machine. Yeah.
That's right.
Over to you, Justin.
Hi, my name is Justin. I just finished my third year at Berkeley studying mechanical engineering, and I'm doing hardware side on Urban Machine.
Hi, I'm Aashika. I am finishing my second year at Berkeley, also doing mechanical engineering, like the rest of them. And I am working on sustainable design at Urban Machine.
Yeah, very cool. And that's really it sort of represents the pillars of the Urban Machine team, right? We have like software, hardware, product all coming together. So it's a good cross section of type of things we work on here.
Absolutely. Had any of you guys ever taken a class together before? Just curious, like, had you it?
Yeah,
We had in one of our classes.
we were in the same project group
Yeah.
actually.
Oh, really?
Yeah, in our PCB design, it's like a student-led decal, and we were in the same project group together. So we made like a cool project. It was like a cool little video game thing where you can play Pong using two controllers. Where we designed the PCBs for them.
Yeah.
Yep. And that's how we met last semester.
And so did you
That's
know?
incredible. So did you realize?
Yeah, same question.
You mean no? After I saw like, a post on LinkedIn, and I saw him at the X drawing,
Yeah.
I was like, hey.
I know you. That's awesome. Well, it's been a great summer having you guys. You all bring your own energy and your own creativity to the team. So I know everybody's enjoyed having you around. And I'm looking forward to hearing more, since I'm not there, about what you guys do on a day-to-day basis. Aashika and I communicate pretty much every day, so I know more about what she's up to. But yeah, Andrew, let's find out.
Yeah, absolutely. So we'll start Samuel on your side again, I'll just set the stage a little bit, which is a big part of our workflow is identifying fasteners in the reclaimed lumber. Right, that's what we're doing here, pulling nails out. To do that, we have to use 3D sensors, and these sensors they're expensive. It's not always clear how they stack up relative to each other. We've been using a sensor from a vendor that's helped accelerate our process tremendously and got us really high quality data. But we've always been kind of left wondering, like, what does that landscape look like?
Yeah.
Is there other avenues we could go here? Are there there's always trade-offs with these sensors, right? So when Samuel came in, it was that was kind of the tee up for like, let's do a little bit more exploration here. So there's more juice to squeeze.
So when I came in, like the robot was working great. It was good, but there was always a question on could we do it faster? And so I think when Alex was the one who like brought up a new camera, and like he wanted me to evaluate whether it was gonna be better for us in our whole pipeline. So uh, so that was one of the things I was tasked to deal with, and I think um, one of the challenges I faced with like integrating this new camera initially was just understanding the whole robot stack, because that was something that I wasn't very familiar with. So there was a whole process of getting to understand how the current camera fits into the whole pipeline. How do we get the point cloud data? How do we know where the nails are on the wood? And once I was able to figure that out, then I could properly start to check out how this new camera was like. And yeah, so
Yeah. And so you mentioned a key thing here. We're always sort of thinking in systems here, right? And it's always those interfaces between different parts of the system that are so important, right?
Yeah.
And if you're gonna get and replace a really critical component of the system, you want to make sure that those interfaces are
Yeah.
consistent,
yeah.
right? Or else you're gonna have to rewrite substantial portions of the
Yeah,
stack.
that's exactly right. In fact, like I was just telling Alex that actually like the robot stack is pretty robust, and it was um the part that took the longest for me was more understanding the robot stack, but the actual integration actually didn't take that long because it was already like very well built from the start. So swapping things out, I think in terms of scalability, the code is pretty robust, and yeah, that's something that it's actually new to me, and I really appreciate that actually a lot.
Yeah.
Yeah.
Did you feel like as an intern, there's this pressure, of course, to to perform? Anybody new at a job feels that same kind of pressure. Did you feel the mentorship was solid, that you were able to learn and also not be on the leash? You know what I mean?
Oh yeah. Yeah, I think like for this internship, it was well. So Alex was my mentor, and is my mentor, and then so like I think he was really helpful in guiding me as to whenever I had any questions, and so I think initially the pressure to perform wasn't as strong because I was just trying to figure out what to do, and I think Alex was pretty understanding that there's not much you can expect from someone who doesn't really know what's going on, right? So it was more like over time, as I began to understand how things went, and so then I was able to like add my own flair to stuff, like actually do stuff on my own. Yeah,
That's exciting.
it's been really nice.
Yeah. Well, that hands-on experience that you don't, you do get it in class, but it's a whole new level, right?
Oh, it's pretty better. Yeah.
Awesome.
And maybe now's a good time I can share an image and Samuel, you can describe what's happening in this image here.
Samuel, I have to tell you that this
Let's see.
image, when Alex shared it, that was the inspiration for, this theme week of interns and spotlighting all that you guys have done this summer. It's really important that you
Right.
share.
There we go.
Look at that. I love it.
All right. So let me explain to you why I was so happy. so this so this integrating of this new camera took much longer than expected because this new hardware that we had was advertised to be able to scan or we were theoretically supposed to obtain point clouds much faster. But as I dug into the code and what the APIs that were provided, it turns out that they were still in development. And so, like, to integrate it into our stack, it required quite some engineering. So what I had to do was I had to like be in contact with them a lot and see what they had that was existing. And I kind of had to understand their product like really deep inside. And so yeah, essentially I was like writing like code that was like a lot of their stuff was in C++. And so I had to write it in Python. That would be nice for our library to take in. And so what you see in this photo over here is after a few weeks, we finally managed to get I forgot to mention. So the main challenge we had actually was that for this new camera that we had, the depth map and like the RGB image were not aligned. So how our original camera worked was that when it took an image, it would have depth information behind every pixel. But for this new piece of hardware, the depth camera and the RGB camera were located in like separate positions. And so the resulting image that you got for both cameras was like from a different perspective. And so what I had to do was to align these two images through certain transforms. And after I was able to align it, I was able to get like the RGB image with the depth information from the right perspective. And yeah, so after I got that working, I passed it through our robot stack. And this image shows the inference working, which means we were able to detect nails using the new camera. And so that was really exciting because that was like just a validation of all the work that had been put in. Yeah, it was not for nothing. Yeah.
That's awesome.
Yeah, interface achieved.
Yeah, interface. Yeah.
Yeah, and performance as well.
Yeah.
Yeah. It's a phenomenal result. It's going to unlock a lot of other features that we've been wanting to put in the robot that have been sort of roadblocked by the old hardware. So now this unleashes a whole other, like multiple development pathways that we can take forward. It's super exciting.
Congratulations, Samuel.
Awesome. Yeah. Oh, yeah. Huge. Yeah. So maybe we can slide over to Justin, and maybe I'll just also briefly set up your project. So we, on the hardware side, once we get the beautiful inference data from the software team, we have to go pull those friggin' nails out, and that involves what we call as the Big Bird, which is a robot gantry with this pneumatic beak that goes in, picks and pulls the nails out. And in the hardware land, we're moving fast, we're iterating quickly. And there's some fundamental questions that we just haven't been able to answer because we just didn't have the infrastructure around it to understand, like, well, what are the specific pull forces in these various scenarios? How is the hardware performing? And like, can we get more insights in there to better drive engineering decisions on the hardware side? That's where Justin came in.
Yeah. So my project over the summer, or my main project over the summer, was building a test stand so that we could test out different types of geometries of the jaws, or what we call the jaws, or the end effectors of the robot arms. And so, like, when we want to test out different types of jaws, like, it's very difficult at the current state to be able to do it because you'd have to basically swap off, like, an arm off the entire robot. And that leaves the robot basically decommissioned for a while you have to, you test out a different arm on it. And it's really inconvenient to do so. So we really, as like a company, Urban Machine has not really done that very much. So my project was to build a test stand so that we could try out different end effectors and different jaw geometries.
It's dumped up.
Like a lot easier. Yeah. So we wouldn't have to decommission like the main actor, And if it messes up, then it would only be like the stunt double that gets injured.
Yeah, and maybe another important detail is like our one other robot is in production. Like it's like basically on the factory floor producing material. So any development we do on is directly robbing for production at this point in time.
Yeah.
Right.
Yeah. So I built a test stand with a 3-axis load cell that we're going to put onto it, and it'll let us measure the different forces that we need to be able to pull nails out. And so that'll tell us which geometry of the claw allows us to best pull nails, or allows us to most easily or most reliably pull nails out. And it'll tell us, different, like if there are forces in other directions that we have to account for when we build our main robot. And then that can inform us that information is really valuable to us. It can inform us when we're making decisions on designing the robots laying down the road.
That's awesome.
Absolutely. So what were some of the aspects of it that made it maybe a little trickier or like not obvious going into it?
Yeah, so I think the hardest aspect was like basically transferring the design from CAD or from the design point to the physical actual product. And there was a lot of things that I didn't really account for that I should have that I'll learn to account for in the future, which is really nice. One of the biggest points was we laser cut a lot of our pieces out of metal. And something that you have to account for that I didn't was the focal point of the laser. So if you have a thick piece of metal, the laser, similar to like what a camera will do, has a focal point where all of the light rays or all of the laser rays will pass through that specific point. And then when it passes through that point, after it goes there, it starts to unfocus similar to your camera. So things beyond the focal point will be out of focus. And that means the light rays are spreading out and they're not like clumped together. And so with the laser, or when we laser cut these pieces, the focal point will be somewhere in the middle of the piece. And when you do thick pieces, there's going to be a lot of the piece afterwards, that focal point, that the laser won't be focused onto. Uh, this can cause like really, it can cause some pretty significant changes in the geometry that I didn't account for. And so when I designed all these circles to be cut in, where I would put clamps into for my test stand, the circles actually were the correct size at the very top and in the middle of the piece where the focal point was passed through. But on the bottom of the piece, after the lasers spread out, it wasn't strong enough to fully cut through the piece where I wanted it to be cut through. And so the circle actually got ever so slightly smaller. And I didn't account for this in my design. And so the clamps that I wanted to put into there actually didn't end up fitting. And there was like, I think there was 18 of these circles in total on my piece. And since the clamps wouldn't fit at all, when I tried to press them through, I had to go in with a Dremel and manually by hand make those circles slightly bigger so that it would actually fit in the end. So it was a pretty painful lesson, but I'm glad I learned it.
Yeah, time
Yeah.
constraint.
Able to improvise and get there. That's like
Mhm.
probably more common than people want to admit in hardware is like when you get it in and you use the tools you have on hand
Yeah.
to make it work.
Right.
Yeah, yeah.
And hey, listen, that's kind of what this whole
Oh,
show is based on, things that have gone wrong and how you fixed it. And, I think everyone can relate to having to go back and fix something. So it's good.
Yeah.
And you had Andrew as your mentor, right?
Yeah.
yeah, the hardware. We've sort of shared Justin across the hardware team.
Yeah. I got passed around.
Well, that's
But it was
lovely.
great. I mean, I think the company does a good job at like making me comfortable to be able to ask questions and like learn a lot of things. Even though I don't like know a lot coming in, I was able to ask a lot of questions and learn a lot.
That's great.
And now I'll share a
This
couple of
is,
shots of Justin.
I love this picture.
There we go. Yeah. So that's great. So that's the test stand
Not this
in
one.
action. Maybe the first thing that's striking is it's pretty big. The robot is pretty big, and it has to be pretty burly, right? Like you had to design. What was the main sort of z-axis load the extreme load you're working with on this thing?
So on the actual robot, we could go up to around 800 pounds, and I wanted to make sure it was safe, and so I put a pretty big factor of safety on there, so it can definitely withstand up to around 2,000.
Yeah, so pretty powerful. And then let's see. I think yeah. So here's Justin. Actually, just this morning, we're working on his next project. Slamming through some tube steel.
Yep.
And about to do some welding this afternoon. So like definitely getting his hands dirty in the shop, using all the tools, and just being a hardware killer out there.
It's amazing.
Yeah.
The last picture, Alvaro's face is like proud papa. Like,
Yeah.
that's my guy. I love it. Awesome. Well, thank you. I'm glad you had a good experience. And then Ashika,
Yeah.
you've been busy. You have your hands in a bunch of stuff too.
Huge project. Yeah. We talk about the phone booth. Yeah. So one thing that we lack here at Urban Machine is office space and places to make calls. And a new phone booth is like several thousand, $10,000. Right? But we're surrounded by reclaimed lumber. Why would we go buy a phone booth? So Ashika, that's where it starts there.
Yeah, so like Andrew said, I'm designing soundproof phone booths for the office here to go in our warehouse. And yeah, it's been great using the reclaimed lumber. I've never worked with reclaimed lumber before, or actually lumber in general. So this was a learning experience for me as well. It involved a lot of CAD before finding the right dimensions that I needed. And I think one of the main things I wanted to do was use things that are already existing, like the reclaimed lumber, and not cut it down to less widths than I need, just to use things that come right out of the mill and not waste material. So one of my focuses was using the dimensions that already exist, like 2x16 glulam are very common in general in construction. So using the 2x16 pieces as is and not cutting it down to like 12-inch pieces. That was kind of my design consideration when I was designing the phone booth. And I think, yeah, my main focus was using the material that already exists in the world. And we also used recycled doors from our last warehouse and things like that. So it was using a lot of things that already exist and learning how to make them fit together rather than designing things that would produce more waste.
I love that. Keeping it circular. That's the
Yeah.
way to do it. And
Yeah,
Yeah.
yeah,
and what kinds of hurdles did you have to jump in learning how to?
yeah. I think one of the main things was using the reclaimed lumber. There aren't very many material specifications on reclaimed lumber, on the wood that we're using, and in general, we don't really know where it comes from. So when I was trying to simulate the booth and simulate different furniture pieces that go in the wood to make sure that it's not going to fall apart, I had to include a lot of material specs myself and kind of add a factor of safety in the yield strength that I put in, because it's possible that the wood that we're using is different than the wood that is conventionally used in other construction sites. So a big factor in what I was doing was making sure that I put the maximum factor of safety on any simulation I'm doing, just to make sure that when people are actually in the phone booth, there are no hurdles that they experience, which was my biggest consideration. So I think a lot of the time I was spending researching a lot of different construction sites and a lot of different spec sheets to make sure that I'm aggregating the data and using all the information I had. And obviously, since I've never designed using wood before, I was also nervous about making a whole phone booth that people would sit in and walk in and things like that. But again, the engineers on the team were very helpful and open. And one of my first reviews, I got a lot of really good feedback, and they basically told me to just go for it, to not be as worried, and they'd be there if I ever needed any help. And I think it was, like Justin said, really great to know that there's always people around if I have a question, if I'm in the middle of cutting something and I don't know what I'm doing. There's always someone in the shop or in the office I can go to. So I think that was a very cool lesson to learn in industry in general, that there's always people to help, even though it seems like everyone's busy at some point.
Oh, I love that positivity. I mean, that is how you learn, right? I mean,
Yeah.
if you're afraid all the time, you're just not going to learn nearly as much as, having someone on your side. That's great. I'm so glad to hear it. And your project is coming along amazingly. I
Yeah.
can't wait to see it in
I'm
person.
gonna share.
Oh, good.
Jory, maybe we'll have to do a podcast from the phone booth. Once it's done, we'll have it. Yeah. Okay. Here we go. So this is mid construction, right? So what are we looking at here, Ashika?
Yeah, we're looking at, this was actually yesterday, when I got the walls in, and you can see some ratchet straps that are on the wood to keep the walls together. So one of the challenges was we can't find big enough clamps to clamp 87 inches of wood together. So this was our solution, is finding ratchet straps that kind of compress the load and keep everything together. I'd also never used ratchet straps before, so it was some YouTube and some people in the shop that were helping us. got at the end, and now I feel like I'm a pro in Raffles Garden.
Yeah, the other side has like really long tube clamps on it too, right? Like the tube clamps are pretty cool. You see that long piece of tube.
And they're so strong too. They're made of iron, so they're not gonna unclamp at any point, which was a concern with some of the smaller clamps that we have.
Super cool. I think I have one other. Oh, there's the tube clamp there.
That's the tube clamp.
Yeah, exactly. Holding it across the side.
Yeah, it's 5
Yeah.
feet long.
Yeah. So how many, man, I'd love to, how many different types of clamps did you have to use? I feel like that's a classic woodworking thing.
Third different type of clamp, which was made of metal, so it was also really strong. And I used it for loads that were more than 2 pieces of wood because you would need a lot more strength to keep those together. I'm going to use ratchet straps as another piece of clamping, so 4.
Nice. That's a good, yeah, that's a good base.
Yeah.
Yeah. One other detail I'll share is that I think very thoughtful is that there's good amenities, there's lighting, and there's also exhaust and a fan
Yeah.
in there, which if you've ever been in a phone booth where someone's forgot that you need ventilation, it's pretty punishing. So that's like very thoughtful to have that detail so early
For
in the design.
sure.
Yeah.
That's awesome. That's really smart. And what about in the winter? Is it heated? I'm just kidding.
Well, the wood would be insulated, so
Yeah, that's right. I guess as opposed to a lot of material, like wood is fairly decent insulator. Right? Yeah.
works
And
both
sound.
ways. Yeah.
That is good.
Yeah.
Because
think
it
we
gets
just-
cold in that warehouse in the winter.
Sure does. We got the heat lamps. It's fine. We're roasting now, but it won't last forever. So here's the three of you out in the shop. Yeah. And here we go.
That's awesome.
Here we
When
go.
are you guys all graduating?
Fall 2024.
Fall 2024.
Spring of 2024.
Okay.
So spring 2025.
Okay. That makes sense. Well, I mean, this experience, I know I asked you guys before the show. Boys, you both have already had internships, but Aashika, this was kind of your first one. Will you try again next summer? Have another internship?
Yeah, I definitely think so. I think I was at a point where I was figuring out if I wanted to do research or an internship. Last summer I did research, and I usually do it for the semester, so I think that was my major decision. But when I talk to other engineers in general who are in industry or do research, everyone kind of advised me to try something new, and it's for a summer anyway. So if you're in Berkeley and in the Bay, might as well use all the startups that are around and learn from them. And I think that was honestly the best decision. I did not think I had a good picture of industry going in. I thought it was a lot of just sitting at your desk and figuring out how to figure out the yield strength of a specific material. But I think it was really good to come in and learn about the hands-on side and the collaboration that also exists in industry and in general.
That's awesome.
Especially
Go ahead.
Yeah.
What did you say?
in terms
Andrew?
of the opportunity. It's the Bay Area is such a special place to be in terms of the opportunity to get access to industry, especially in like crazy startups like
Yeah.
Urban Machinery. People are doing these wild things. It's a lot of hands-on and kind of figuring it out as you go. It's like the ultimate problem-solving experience. Everything else can get thrown your way.
It's true. I mean, I think also just that variety, the fact that, like Aashika, you said, doing something different this summer, how are you going to know exactly what you want to do unless you just kind of try everything and see what fits the best. So I'm glad that Urban Machine was able to give you guys a good experience. I know we all definitely benefited from you being with us this summer. So thank you.
Absolutely, yeah. Even though this is the second summer we've had interns, but fall is always the tough time when you guys go back to school and you realize we don't have the horsepower that we did previously.
Yeah.
from that. Yeah, but yeah, it's really awesome having you guys all on the team, seeing all the awesome talk.
Yeah, and thanks for being on our show. I really appreciate it. It was a good one. If you want to
Yeah.
know more about our machine, you can go to our website, machine.build. And there's a contact page if you want to contact us about buying some reclaimed numbers so that you can also build yourself some dream phone booth and anything else that you can dream of. All right. Thanks, everybody.
Thanks so much.
Bye.
Bye.